write them down or whatever. You could look in a random table if you want to, that kind of thing. Here's what my survey says. 5, 3, 1, 2, 1, 0, and 0. Now yours might be different. Again, if we started at a different place in our random number generator, that's what I saw in my results. So the question is, which one had, we use technology, not a table, technology. And so which one had a longer run?
Technology.
What technology did. So I'll just write down technology. And how much longer was it?
2.
So it was a run of 6, which was 2 longer than the other trial. Second myth. The law of averages is when a long streak of a certain outcome occurs, the future must make up for the imbalance. And that was what I was talking about a little bit ago, that if we all took a coin and flipped it, the 30 of us, there is a likelihood that somebody would flip, I don't know how big the likelihood is, that somebody might flip 10 heads in a row. Does that mean somebody in the class has to flip 10 tails? Nope, it doesn't. That's a myth. It could happen, doesn't happen. Doesn't have to happen, excuse me. If we take everybody on the planet and do this, is it likely that that's going to happen? Yes, it's likely that that's going to happen, because that's a very large, actually that's our population, but the chance that that's going to happen with a very large sample is there. But in small sample sizes, that's not necessarily true. Like in chapter 4, when we were doing our experimental design, we drew a diagram, then we wrote some stuff out. This is where things get a little bit wordy, and you have to explain things in detail. Okay, so it's really important that when you're talking about experiments or simulations like we are right now, that you provide detail. So a simulation is an imitation of some kind of chance. And it's carried out with random numbers, either from our table or calculator. You do it other ways, but those are the two most common in our course. There are 4 steps. Number 1, state what you're doing. So you're formulating a question about something of interest. Number 2, plan. That means lay out what's going to go on. How are you going to use this chance device, whether it's your table or your calculator, to simulate what is going to be happening in each repetition. And then number 3, do it. And then number 4, draw your conclusion. So for example, we have a local high school where 95 students have permission to park on campus. Each month, the student council holds a golden ticket lottery at a school assembly. 2 lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn by a student council member from the AP Stats class. When both golden tickets went to members of that same class, of the same class, some people thought it was rigged. There are 28 students in the AP Stats class, all who are eligible to park on campus. Carry out a simulation to decide whether it's plausible that it was carried out fairly. So let's take the 4 steps into account. Step number 1. We're going to state what's of interest. So that would mean something like, what is the probability that a fair lottery, that word fair is very common in statistics, would result in 2 winners from the AP class. Number 2, we're going to plan, or in other words, design what's going to happen. So we will use Table D to simulate the choosing of the winners pick a 2-digit number if the 2-digit number is 0, 1 to 28, they are in AP Stats. 29 to 95 is not, and 96 to 00 ignore. Okay, so then we pick 2 winners and note if both are from AP Stats. You'll find out later that there's a certain size sample that makes it very convenient to whether or not you have a good sample size. In statistics, it's often 30. So I'm going to say we will repeat 30 trials. Information.
We're moving on to step 3 now.
I'm going to do now number 3. What's number 3? Do. So I'm going to do the experiment. I'm just going to write down the numbers that came out of the table. Usually most people, I start at usually the first line, so here's what I see. Tell me if I got this right. 1, 9, 2, 2, 3. Are these the first 5 numbers?
Yeah.
Okay. 9, 5, 0, 3, 4. 0, 5, 7, 5, 6. Is it 28713?
Yeah.
26 or 96?
9.
96409. 12531. There are a lot of numbers, so I might have to go on another page. I don't know. 42544. 82853. 73676. 47150. What's the next number?
9.
99400. 01927. 27754. 42648. 82425. 36290. 45467. 71709. 77558. Is it 00095? I hope. Actually, it's not even a matter. 32863. 29485. 82226. 90056. 52711.
So on the actual question on the FRQ,
38889 93074 6, I don't even know what the number is, 0227. I think that's it for those lines. Okay, so now the big idea is just check to see if those 2 people in a row are from the AP Stats or not. So I look at the first 2.
Yes.
Here's the first 2. Were they both from AP Stats?
Yes.
Yes. Then I go look at the next 2. Were they both from AP Stats?
No.
No. Then I go look at the next 2. And I continue to do this in my trials. So in case you're not understanding, person number 19, AP Stats person, because it was 1 through 28. Person number 22 was 1 through 28, so they're from AP Stats. So this first yellow group is a yes. So I can keep a tally off to the side. I can go, okay, I know right now that my yeses and my no's, here's 1. I got 1 yes. And then I got a no. And then I got, are they both from AP Stats? No. So that's a no in the yellow. And then the second green, are they both from AP Stats? No. Okay? And you have to ignore certain ones, right? So I look along and I go, oh, the 96. What about the 96? You ignore that. So you don't look at that one. You move on to the next thing. So 96 is ignored. So I would have 4. Sorry. I would have 40, and I ignore. Do I ignore the 91? No. Okay. And 91. So that's a no. And I continue to do this until I tally up how many were yeses and how many were no's. Okay, so if I do that and I get done at the end, I find out that there was, in total, only 1 yes, and there were 29 no's. Meaning, only once did both winners come from the AP Stats class. That's what it means. As I do the same process all the way through. Notice how this 96 over here was discounted because it wasn't the 1 through 95. I don't even look at it. I pass over. Is that making sense? Step 4. I ran out of room. All right, so based on our simulation,
Nice.
there is a 1 in 30 chance of both winners coming from the AP class. And you can use a decimal representation, that's 3.3% or something like that.
That's pretty small.
Which is a very small chance. It is highly unlikely that 2 winners would occur but the lottery may be fair. So if we had to guess, is this a fair lottery or not a fair lottery? You would probably guess that it's not, because you would only expect this out of 100 times of doing this, you'd only expect to see it 3 times where that would occur. That's a very small chance. If you're a person who's using mathematics to justify your reasoning, you'd say this is probably a rigged lottery.